Good morning. Today we are going to be doing functions guided by the paper from the Department of Basic Education written in November 2013. When you come across this video, don't forget to subscribe, share, like, and comment. So we are on question 4. We are given that if x is equal to minus 2x squared minus 5x plus 3, then we go to question 4.1. 4.1, they are saying write down the coordinates of the y-intercept of f. So we need the y-intercept. How do we get the y-intercept? We substitute x equal to 0. So it simply means where we are having fx here, we substitute by our y. So it therefore means that our y is equal to so y is equal to minus 2, 0, squared minus 5, 0, plus 3. Y is equal to 3. Then because the question wants coordinates, we write our answer as coordinates, which is going to be 0, 3. So here our answer is 0, 3. Then we go to question 4.2. They are saying they want the coordinates of the x-intercepts of f. We want the coordinates of the x-intercept. So it means our y, to get the x-intercept, our y will be equal to 0. So it means there our 0 is equal to minus 2x squared minus 5x plus 3. Then here it simply means that our a is equal to a negative 2, our b is equal to a negative 5, and our c is equal to positive 3 from this standardized quadratic equation. So we apply the quadratic formula, copy the quadratic formula from the formula sheet. X is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So this will be equal to minus b is minus 5 plus or minus the square root of b squared, which is minus 5 squared minus 4a is minus 2. Then c is 3 all over 2a is minus 2. Then we trust the calculator. So when we go to the calculator, what are we going to get? So it's minus b, so minus 5 plus the square root of b squared, which is minus 5 minus 4a is minus 2, c is 3 all over 2a 2a is minus 2. We are getting minus 3. Then we put minus there. Our answer is minus 3 or half. So it therefore means our x is equal to minus 3, or our x is equal to half. Then write the final answer as coordinates according to the requirements of the question. So it means we are going to have minus 3, 0, or half, 0. So the final answer here is minus 3, 0, it's end, half, 0. Those are our coordinates. So take note there. Alternatively, we can use another method. We can use factorization, or we can use completing the square to solve that. So if we were to use factorization, it simply means we are going to have our equation, which is 0 is equal to minus 2x squared minus 5x plus 3. Then here we want the product is the first term multiplied by the last term when your equation is in standardized form. So it's going to be minus 6x squared. Then the sum, we take the middle term, which is minus 5x. Then the factors, we want two numbers. If we multiply them, we are going to get minus 6. Two numbers, if we multiply them, we get minus 6. So we can get minus 6 and a positive 1. We can get 1 and a negative 6. We can get 3 and a negative 2. Or we can get a negative 2 and 3. But the pair of numbers, when we add them, we must get minus 5x. We must get minus 5. So which one is going to give us minus 5? We say is this first one, then the other ones are out. So where there is sum, it means we are now going to substitute there by minus 6x plus 1x, which is plus x. So where there is sum, we substitute by those factors. So it means our 0 is equal to minus 2x minus, it's minus 2x squared minus 6x plus x plus 3. Then we factorize by grouping. So we concentrate on the first two terms. The common factor there is negative 2x. Then we are left with x plus 3. Then we go to the last two terms. The common factor there is plus 1. Then we are left with x plus 3. Then the repeated factor, we are going to write it once. So we are going to have a 3. Sorry, it's x plus 3. Here, x plus 3. Then the other factor will be minus 2x plus 1. So from here, we equate each factor to 0. X plus 3 equal to 0, or minus 2x plus 1 equal to 0. Solving each. So here x is equal to minus 3 when we transpose that one. The other side here, it means minus 2x will be equal to minus 1. When you transpose the 1, when you divide both sides by a -2, so the x will be equal to half. Here, x is equal to -3 or x is equal to half, which are the same solutions that we get. Then you remember to write your answer in coordinate form as per the requirement of the question. Then we go to the next question. They are saying determine the coordinates of the turning point of F. That is question 4.3. 4.3. So, given from our function, knowing that we know A, we know our B, we know our C, the x value at turning point is equal to, the x value at turning point is equal to minus B over 2A. So it means our x is equal to minus, and our B is minus 5 over our B is minus 5 over 2. Our A is minus 2. So this is equal to -5 over 4. Once we get the x value, to get the corresponding y value, we need to substitute the x value in our equation. So it simply means our y value will be equal to -2, open bracket, minus 5 over 4 squared minus 5 over 4, where we are supposed to have x plus 3. Then we go to our calculator. We substitute on our calculator. So substituting on our calculator, we are going to get so it's going to be -2, then bracket minus 5 over 4 squared minus 5. Then we are going to minus 5 over 4 plus 3. So it's 45 over 8, 49 over 8. Then eventually the answer, because the question wants coordinates, so this is going to be -5 over 4 is to 49 over 8. So here it's going to be -5 over 4, then 49 over 8. Alternatively, to get the x value at turning point, so to get the x value at the turning point, considering that we know the x-intercepts, considering that we already know the x-intercepts, this minus 3.5, it means this x at turning point will be equated to the sum of the x-intercepts divided by 2. We just take the x-coordinates, so it's going to be minus 3 plus a half divided by 2. This will be equal to, we can go and verify that using our calculator. So it's minus 3 plus 1/2 divided by 2. That is giving us minus 5/4. It's giving us minus 5/4. Once you get this x value, we substitute it in the original function. Again, alternatively, it was possible that to get that x value at turning point, we have to know that at turning point, the first derivative will be equal to 0. So we are given that fx is equal to minus 2x minus 2x squared minus 5x plus 3. Therefore, we get the first derivative. This will be equal to minus, we bring down the power, it multiplies by this coefficient, so it becomes minus 4x, because on the power we subtract 1 here, minus 5. But we have to know that at turning point, the first derivative is equal to 0. So equating minus 4x minus 5 to 0. So it means our negative 4x will be equal to positive 5. When we divide both sides by a negative 4, conclusively, our x will be equal to negative 5/4. And once we get the x value, we substitute in the original function to get the corresponding y value, so that we leave our answer as we leave our final answer in coordinate form as per the requirements of the question. Then we go to the next question, which is 4.4. On question 4.4, it's saying sketch the graph of y equal to fx, clearly showing the coordinates of the turning point and the 3 intercepts. So what is very important here, our function is fx is equal to minus 2x squared minus 5x plus 3. So when sketching a quadratic function, number 1, we need to know the shape. So to know the shape, we have to check on the value of a. If a is negative, the shape of our graph will be like this. If our a is positive, the shape of our graph will be like this. Then, because here the shape is a parabola, then we need the coordinates of the turning points and the 3 intercepts, which is the x-intercepts and the y-intercepts. So to sketch that graph, since our a here is negative, it means our graph is going to be like this. Then here we are having our x-intercepts, which is minus 3.5. Then here we are going to have our turning point there. The coordinates are minus 5/4 is to 49/8. Then the y-intercept is on the right of the turning point. This is y-intercept, this is x-intercept, this is the origin. Then the y-intercept there is 3. So if you check, it's saying clearly showing the coordinates of the turning point. They are already highlighted, and the 3 intercepts. We already highlighted the intercepts. Then we label our graph. This is f. And because our graph is continuous, it's going to be going, show it with the arrows. So this becomes the solution for 4.4. There is your 4.4. Then we go to the next question. We go to the next question, which is question 5. So here is our question 5. The question reads, sketched below are the graphs of gx equal to k to the power x, where k is greater than 0, and y is equal to g inverse, the inverse of g. Then you are told that the coordinates 2, 36 is a point on G. The first part is saying determine the value of K. Determine the value of K. So we go to question 5.1.1. So 5.1.1, we want the value of K. So since K is a variable in the function gx there, and we have a point on G, it simply means we have to substitute the coordinates. Here is x, here is y. We substitute the coordinates in the function g. So it's going to be where there is y, taking note that here our g, that's where our y is. So where there is y, we are going to put 36. So it simply means that 36 is equal to, we are saying y is equal to k to the power x. So 36 is equal to k to the power x is 2. Then to solve that, we are going to get the square root both sides. But we are not going to put plus or minus y, because we are already told that k is positive. K is greater than 0. So we can therefore conclude that k is equal to square root of 36, which is equal to 6. Then we go to the next value. It's saying give the equation. It's saying give the equation of the inverse. So to give the equation of the inverse, so we are having y equal to, as the equation of the original equation, y is equal to 6. It's k, which is 6 to the power x. That is question 5.1.2, which needs the equation of the inverse. When you want to get the inverse, the first step is to interchange x and y. So it means x is equal to 6 to the power y. Then the next step is to make y the subject of the formula. So it means y, therefore, y is equal to log our base is 6. So it's y is equal to log x base 6 there. Y is equal to that. This is here we are using the definition. If you are told that A is equal to B to the power M, we can convert this using the relationship between logarithms. You have to know that if we are to convert this one, it therefore means that log base will be base number, which is A, must be equal to M. This is what we applied here. So we got that. Then we go on question 5.1.3. They are saying for which values of x is the inverse less than or equal to 0. So the inverse here is the graph of the inverse drawn, but when they say less than or equal to 0, we want, if they say less than 0, we want the part which is below the x-axis. So if I am to mark that, it means the part that we want is from this, because is from the x-intercept going down, because they said where g is less than or equal to 0. So we want the part which is below. So here the x-intercept is 1, 0. Remember, we have to interchange x and y. This was y-intercept. So when we go to the inverse, what was the y-intercept becomes the x-intercept. So it means the part which is highlighted in red there is the part which is less than the x-axis or equal to the x-axis there. And you have to take note that at this y-intercept, this is an asymptote, so the region that is wanted is from 0 to 1, but 0 being excluded because 0 is an asymptote. So it means the solution there is going to be 0 less than x, and x is less than or equal to 1. Here it's inclusive because that x is an intercept of that graph. Then we go to the next question, where they're saying write down the domain of H. Write down the domain of H. So if we are to check here, we are on question 5.1.4. If H is this, so first we are going to deal with the inverse, that one. What is the domain of the inverse? What is the domain of the inverse? So what is the domain of the inverse? So we can start from domain of the inverse. The domain of the inverse here, if we check, here is the graph of the inverse, and here is the graph of the inverse. So the domain, as we can see, is x is greater than 0. There, x is greater than 0. Since the equation of this asymptote y-axis is x equal to 0. So the domain is from this x-axis going to the right. But now the question wants the domain of H. The question wants the domain of H. But if we check H, it's showing some transformation is the inverse of that x minus 3. But this x minus 3, it simply means that, plus here, we got y equal to log. Then here we got from 0 to 1 inclusive. So here, this transformation, it simply means the graph has been shifted 3 units to the right. So if the graph has been shifted 3 units to the right, it means our asymptote is now at x equal to 3. So it therefore means that the domain of h from the original there, it means it just shifted 3 units to the right. So it becomes x is greater than 3. And we have to take note that x is an element of real numbers. So here the domain becomes x is greater than 3. We also have to know that x is an element of real numbers. Then the next question is saying that is 5.1.5. Oh, it's 5.2. 5.2 point 1 is saying sketch the graph of the inverse of y is equal to 1. So the process of inverse, we just know we interchange x and y. So the inverse of y equal to 1, it simply means where there is y, we are going to put x. So the inverse is going to be x is equal to 1. So if we are to sketch that graph, we need, here is our x-axis, here is our y-axis, our origin, and y is equal to 1 is a vertical line. Sorry, x is equal to 1 is a vertical line. It's just a vertical line. Then the next question is saying 5.2.2. Saying, is the inverse of y equal to 1 a function? Is the inverse a function? No. No. It's not a function. The inverse of that one is not a function. Why is it not a function? Why is it not a function? Because there are more y values for a single x value. It's because there are more y values for a single, because as we can see here, when x is equal to 1, y is equal to any number. As we can see here, y lies anywhere. When x is equal to 1, there are many values of y. So because there are more y values for a single x value, so it's not a function. That's 2 marks there. Then we go to the next question. Question 6. Right. We are given here. We are now on question 6. Then we are told a sketch of the hyperbola fx is equal to x minus d. So it's question 6. They said fx is equal to x minus d over x minus p, where d and p are constants is given below. The dotted lines are asymptotes. The asymptotes intersect at p. B20 is a point on f. Yes. Then what are they saying? Then the first question is saying determine the values of D and P. So if we are to check here, we have the equation of the vertical asymptote here from the graph. We have the equation of the vertical asymptote from the graph here. How is it given? We have the equation of the vertical asymptote from the graph here. We are given that x, that is question 6.1.1. So the equation of the vertical asymptote is saying x is equal to 1. Then we can get the equation of the vertical asymptote by equating the denominator to 0. So from the function, because we are given the function, it simply means x minus p is equal to 0. X is equal to p. So conclusively, we can therefore have our x being equal to, our p being equal to 1. Our p is being equal to 1. Then to get the value of p, it means we are having our fx. So to get the value of d, because already here our p is the one on the denominator, so we are saying our p is equal to 1. And we want our d, so our function is given by fx our function is fx is equal to x minus d divided by x minus p, but we already know p is 1. So it's divided by x minus 1. We are now left with d. So to solve for d, we are going to use the point B. So we are going to substitute the point B, 2 as x, 0 as y. So where there is y, here is our y. This is our y. So where there is y, we are going to put a 0. So 0 is equal to x minus d, but our x is what? Our x is 2. 2 minus d divided by x, which is 2 minus 1. When we cross multiply, we are left with 0 is equal to, because here is over 1. When this multiplied by this multiplied by this is equal to 2 minus d. When you transpose the d there, it therefore means our d is equal to 2. So here d is equal to 2. This becomes the values of our d and our p. Then we go to the next question. Then they are saying show that the equation of f can be written as that one. So it therefore means we are now having the equation of, so we are having 6.1.2. So we are having our fx being equal to x minus d, but d is 2, divided by x minus p, x minus p, where p is equal to 1. Then how are we going to simplify this? It means we are going to divide here. We are going to apply long division. If we apply long division, the part on the denominator is going to be this side, is going to be x minus 1. The part on the numerator is going to be this side, is going to be Let's quickly check. Seems we made some errors there. Kindly take note here. We have to take note. The equation of the asymptote is given by x is equal to -1, not +1. Here it is x is equal to -1. So there is supposed to be -1. Then after solving, we are supposed to get our p is equal to -1. P is equal to -1. So since p is equal to -1, kindly take note I had made a mistake here because I had taken it, I've overlooked the negative, it was a mistake. So we are saying x is equal to -1. As you can see from the graph here, the asymptote is -1. So when you substitute the -1, then you make, so our p is -1, not +1. Our p is -1 there. Then when you substitute -1 here, it means it's going to be x minus -1. X minus -1, it gives us +1. So on our denominator, it's x plus 1 here. On our denominator, it's x plus 1. Then take note, we substituted the point 2, 0. Here, it's correct. When you make that cross multiplication, you are still getting, so our d is 2. So here it's supposed to be x minus 2 over x plus 1. Kindly take note there. So our denominator is x plus 1. Then using that, let's go and answer the 6.1.2. So using long division, it's going to be that one. Our numerator is x minus 2. Then x enters how many times into x is 1. Then multiply the 2 is going to be x. 1 times x, x. 1 times +1 is going to be +1. Then we subtract x minus x, 0, minus 2 minus plus 1 is -3. So it therefore means our fx is equal to this remainder -3 divided by x plus 1 plus 1. Alternatively, we can write this as fx equal to x minus 2 divided by x plus 1. Then we are going to manipulate here. This becomes our denominator. It's not going to change. It's x plus 1. So we have to put a term on the numerator which is similar to this one. It's going to be x plus 1 there. But here we are having -2. To have -2 here, it means we are going to have -3. If we simplify our numerator, it's now x plus 1 minus 3, which gives you x minus 2 there. Then from there, we distribute the denominator. So we are going to have x plus 1 over x plus 1 minus 3 over x plus 1, which is going to give us 1 minus 3 over x plus 1. So conclusively, our fx is equal to -3 over x plus 1 plus 1. Then the next question is saying write down the coordinates of P. Write down the coordinates of P. It's 6.1.3. So 6.1.3. If you check from the P, you are told that the asymptotes intersect at P. So P is the point of intersection of the asymptotes, and the asymptotes, as we already know them, we are having the equations as x equal to -1, then y equal to 1. Therefore, the coordinates of P, which is the point of intersection of the asymptotes, is -1, 1. Yeah, it's -1, 1. Then question 6.1.4, we are told write down the coordinates of the image of B if B is reflected about the axis of symmetry Y equal to x plus 2. Then the point that is going to be reflected is B, which is 2, 0. So to get the image, to get the Y value, we are just going to substitute the X value there. So it means Y is equal to, X value is 2 plus 2. So our Y is equal to 4. Then to get the X value, it means we substitute that 0 where there is Y. So 0 is equal to X plus 2, then a -2 when you transpose is equal to X. So the coordinates of the reflection of B is going to be -2, 4. Yeah. So the coordinates of the reflection is -2, 4. And then the last part, they are saying the exponential function gx is given by that is 6.2. We are having exponential function gx, which they are saying is equal to p multiplied by 2 to the power x plus q as a horizontal asymptote y equal to 1. And you have to know that this q tells you about the asymptote. So it means this gx can be written as gx equal to p 2 to the power x plus 1 and passes through that point. So you substitute this point in the equation where there is y, we are going to put our -2, and this is where we are, this gx is our y. So we are going to substitute there by -2. So it means that -2 is equal to p multiplied by 2 to the power 0, which is the x value, using those coordinates here, plus 1. Then you transpose the 1 to the other side, we are going to get -3 being equal to p, because 2 to the power 0 is 1, 1 times p is p. Then conclusively answer the question. It wanted the value of p and q, so it means our p is equal to -3, whilst our q is equal to +1. Thank you very much.